In the previous video, I didn't do a very good job in explaining the first derivative of this. I was going on about this graph, and I was going on about this graph here. So I don't think I did a very good job in explaining. So I'm going to have another attempt here. So when you get to the first derivative here, if you look at this here, we know that as x tends to infinity, the derivative here tends to 0. So we know that the derivative tends to 0. Okay, and then we also know that as looking at this here as x tends to negative infinity, then the derivative also tends to 0. Okay, so this is a graph of the first derivative. It also tends to 0. And then looking at this here, it's also possible to tell that well, when this thing here equals 0, then the whole thing here breaks down. So when this thing here equals this, and we've established this in the previous video, when it equals this here, then the denominator here will break down. So something weird happens at this point here. Okay, so we know something weird happens here. So something weird happens here. So what we do is we select a point just to the left of this point here. So we select a number just to the left of this. So a number just to the left of this, select this, the cube root of minus 2.00000001. Okay, select this number. So this number here is just to the left of this. So when you put this number into here, so hang on, let me start again. So this is our first derivative. This thing here, we don't really know what's going on here. What does it mean to have a power of 4 over 5? So rewrite this as this. Rewrite it as to the power of 4, and then the fifth root, and then take the fifth root. So this multiply this will give you this. So we're trying to understand this here, but we don't really understand what it means to have a power of 4 over 5. So rewrite this 4 over 5 thing as this thing here. So when you have this, times by itself 4 times, and then take the fifth root. Okay. Well, anyway, we then looking at the so we know something weird happens at this point here. So select a point just to the left. So select this point here, the cube root of minus 2.0000 whatever 1. Okay. So select a point just to the left. So if you put this now if you put this into here, okay, so if you put this number into here, and then when you cube it, you will get minus blah 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 here. You will get something like this. Okay, now when you come to add 2 here, then you're going to get so this, when you cube it, it will give you this. And then when you come to add 2, it will give you minus 0.0000 whatever 1 here. Okay, so this whole bubble here becomes this thing here, because when you add 2 to this thing here, it will give you this thing here. Now get this, times by itself 4 times, it will give you a positive very 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 small. Okay, so when you times by itself 4 times, it will give you a positive very 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 small. Okay, and then when you take the fifth root, it will also be a very 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 positive small. Okay, so it would be very very positive small, and when you times it by 5, it's going to be a very 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 positive small. Now you've got this definite answer here. So when you put this into here, it's going to be a definite number. It's going to be a number. So whatever here. Okay, so you're going to get a whatever number here divided by a very very small. So overall, it's going to be very, 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 very big. Now, if it's very, very, very big, then we can say it is pretty much infinity. So what we know is that just to the left of this is going to be positive infinity. Okay, and then you can use the same argument here now. Now use the same argument. Now select a point just to the right. So select the cube root of minus 2.000001, and then put this number into here. So when you cube it, you would get you would get hang on, let me think. Oh, sorry, hang on. I made a mistake here. It should be just to the right of this. Just to the right of this, it should be it should be negative 1.99999 and so on here. So when you cube this, when you put this into here and then you cube it, you would get minus 1.99999 whatever here. And then when you come to add 2, then the whole thing here will be positive 0.0000000 whatever 1. It will be a very, very small number. And then when you come to times it by itself 4 times, it will be a very, 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 very small number. Okay, and then when you take the 5th root, it will be a very, 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 very small number. And then when you times 5, it will be a very, 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 very small number. And then here you've got a definite number. Okay, so yeah, this thing here will be a definite number, whatever number it is, divided by a very, 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 very small number. So overall, it will be a very, 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 very big number. Very, very big is pretty much infinity. So to the right hand side, it will look like this. Okay, and then to the left hand side, it looks like this. And this was the thing that was going on about with this here. In a way, it's quite similar to this. Okay, so the derivative will look something like this. Okay, so whenever you see this here, it means that the gradient is getting very, very this here is your derivative. When you come to look at the actual function itself, this is f prime. When you come to look at the f itself, what it means is when you see this here, it means something like this. Because looking at this here, look at the gradient, it gets very, very, very steep, and then past the critical point here, it's still very, very, very steep. It's still very, very steep. Okay, and then it starts to fall. So whenever you see something like this, the chances are it would be the actual function itself will be something like this. Okay.